All right, so the next problem we're solving on this packet is one that's kind of important, particularly for homeowners and anyone maybe modifying or improving a home, is that about insulation. So I'm going to help you with the diagram here. This is a cross section of a wall, and we want to know the R value uh, of this particular wall, this cross section. And an R value is just a measure of resistance for heat to flow through it. So if it's warm, inside and it's cold outside, a high R value is going to resist the flow of heat from that warm inside to the cold outside, which is what you want, right? You want your home to be insulated. It would also do the reverse too. If you're somewhere in a hot climate and it's hot outside and cooler inside, you want to make it as hard as possible for that heat to flow through the wall. And the R value measures it. So the higher the R value, the greater the insulating properties. There's two problems that we're solving here. We want to know to go right through the wall. So the wall is kind of empty space, and inside here is fiberglass batting. And then down here didn't come through on the copy very well, but that's a 2x4. It's a stud, and we're asked to calculate the R value through the wall cavity and then through the stud construction as well. It's pretty simple. You do need a table for this. You never have to memorize it. But the tables we're just going to go through and look at what the heat has to travel through and figure out what its R value would be. So let me look here. Got a little bit of a glare here, but hopefully you'll be able to see it. Put it here. So all we do is just use the table to figure out what the R value is. For the drywall, 5/8 inch drywall, the R value is 0.456. There's a little bit of calculation for the fiberglass batting, right? Because you could have just a thin strip of fiberglass or a lot of it. And the R value is 3.142 per inch. And the wall cavity is 3.5 inches thick. So we multiply those two values together, and 3.5 inch thick fiberglass batting gives you an R value of 11. And then extruded polystyrene, that gives an R value according to our table of 4. And then the siding, the wood bevel lap on the outside of the house, 0.8. All we need to do is add them together. So through the wall, not through the stud, but through the wall, it has an R value of R16.36. All right, so we're going to keep trying here. The last part is we want to calculate the R value through the stud itself, which doesn't show up very well here, but it's just going from the outside through no insulation, just through solid wood to the inside drywall. So we do the same process. Hopefully this will show up for you. The only thing that's different, drywall is the same. There's no fiberglass batting through this. So the R value for the 2x4 stud is 4.38. Polystyrene and the wood bevel lap is the same. We add all of those up and we get an R value of 9.74. So it's lower than through the wall cavity. And what that means is heat will actually flow easier through the stud than it does through the wall cavity itself with the insulated batting. And that's kind of an important thing to think about. You would like to minimize the area or minimize the heat loss through the studs. So maybe we can apply some special insulation to those as well.